So to get you ready, in case you want to see some more, to get you ready for another problem in the book, here's a book problem. It's number 27. The volume of the solid bounded by the cylinder x squared plus y squared equals 1, and the planes y equals z, x equals 0, z equals 0 in the first octant. And as always, what's hard about this is the setup and making sure you know what you're doing. You don't want to imagine that you have to have a perfect picture here, but we need to have some idea of what we're doing. Well, I've started a drawing here. The cylinder x squared plus y squared equals 1, that's take the unit circle and go up and down with that. I haven't drawn anything else but the circle yet. And then what else we've got? Well, these two are the simplest planes. X equals 0 is the YZ plane, Y and Z being here. So that's going to be the back wall, it looks like. And Z equals 0 is the XY plane. That's probably going to be the floor. So it looks like the floor plan, if we're lucky, is just going to be this quarter circle. Then Y equals Z. That's interesting. That's slanting up and to the right, and it doesn't slant at all in the forward and back direction. So what I did was I went ahead and drew just a line that's supposed to suggest the intersection of that with x equals 0. Again, on the principle that it's not so much the surfaces or the bulk of the body that's interesting, it's the edges and the corners. And in fact, and then the only part of the cylinder I drew so far was this straight up and down piece, because I know that's the intersection of this cylinder with this back wall, and I took it all the way up to where it's going to hit what looks like it's going to be a sloping roof. And so if you can imagine, there's a sloping roof that hits, in fact here, without even meaning to, by drawing part of the axis, that's also one of the intersections as well. That's the intersection of y equals z with z equals 0. So the point here is that there's a geometric process of drawing those edges that corresponds to a very simple algebraic process, which is take any pair of these equations, like x squared plus y squared equals 1 and z equals 0, for example. That's that circle. Any pair of those equations is going to be a possible intersection of these surfaces, and that's going to correspond, there we go, that's going to correspond to an edge that we'd like to draw. So we've got the circle and these two edges here. We've got this coming up, which is where two of the walls intersect. And then what we don't have is the roof, the intersection, which is the sloping roof and the curving wall. Because the cylinder, I didn't draw the whole cylinder because it wouldn't work very well in paint. The cylinder intersecting the sloping roof, that's y equals z, that's going to be the tricky part. But we can freehand that. Well, it's going to look really crappy when I do it probably, but because I'm not an expert with drawing with the mouse and paint. I know what I should be doing this in Google SketchUp or something, but I don't have that installed. And so that's going to be something that traces above this curve, but also comes down because it's sloping down, and it's got to hit this corner here. So let's see if we can do that. It's just kind of tracing down. Oh, and it just wiggles like crazy. It does not wiggle that much. Oh, I want to try and do that better. Maybe this little curve tool would do it better. Oh no, it's not doing it at all. Now, okay, let's try one more time with the pencil tool here. Yeah, except it's supposed to actually go up and meet up here. Yeah, that's not so bad. And so let me draw in some little straight lines up and down to indicate this curving wall, and then I'll draw some lines up here vaguely parallel to the x-axis. Oh, that's terrible. Well, you get the idea. It's kind of this slice wedge with a sloping roof and a curving wall. Trust me, I can actually do a better job of that on actual pencil and paper, but I'm trying this technology, and we'll see if it's actually going to work. So how does that translate in terms of the integral setup? I'll go ahead and do the setup, but not the whole problem. It's going to be an integral, double integral. Now, it's an object with the floor being the xy plane. That's the only kind of object we really know how to do so far. And the height of the roof is, we've seen that that's that guy, so it's just going to be z equals y. So it's just going to be y, and then dy dx or dx dy. Well, that's going to be something where we need to understand the floor plan. Well, the floor plan here, of course, in the xy plane, we've figured out is just a quarter circle And let's see if I can draw. Okay, so it's just going to be this part of the circle in the xy plane. That's pretty symmetrical in terms of whether you want to set it up with dy dx or dx dy, so it's probably not a big deal. So let's just say dy dx. The biggest x can be is 1, and the smallest is 0 in this floor plan. So now, even though I spent all that time drawing this picture, remember, it's not super crucial. As long as you know what everything is, what role is played by all these things, and you don't misinterpret what they do, you don't actually have to have refer back to this picture in detail. The y looks like it's always going from 0. If I look at a strip here in the floor plan, yeah, there we go. A little tiny strip. Come on. Oh, that was trying to draw a circle. That's what I was screwing up. Okay. If you try to draw a little tiny strip in the floor plan, y is going from 0 up to the square root of 1 minus x squared, because that's y in terms of x on that circle. And so that looks like the setup for that integral. Okay, in another video I'm gonna do a little bit more intricate problem where we subtract two volumes from each other, but that's a good one for now.